All right, what we're going to do here is just look at this base saturation percentage and see how relevant this is. We have to move on from that to work on parts per million and kilograms per hectare further down the track, so you can calculate what you need to put on your soil. But when you look at it, you've got to actually understand, when we're looking at a soil, and say we'll say that is a clay soil, and it's a CEC of 15. So we look at it and go, we want to get 70% calcium, 12% magnesium, 3% K, potassium, and 1% sodium. Okay. Now, if we look at that, and if we look at over here and we go, okay, now let's look at a sand soil. And it's got a CEC of 4 to 6. So what happens here is that the same scenario, it's a little bit wrong here, same scenario, I'm going to run out around that. 70% calcium, 12% magnesium, 2% K, and 1% sodium. Hard to fit it all in together. So if you look at it like that, it's like to get 70% calcium in your clay soil against 70% soil in your calcium soil, there's going to need a much larger quantity of calcium. So you can't use just a broad spectrum, oh, we'll just throw a ton of lime to the acre on based on pH. And this is why I was saying the pH is a result, and we have to come back to the size of our soil and the base saturations of what we want to achieve. But to actually understand those base saturations at the next level, we actually have to look at the parts per million in the soil of the cations. And then this is calculated to kilograms per hectare of that particular cation. Now, and that can be pounds per acre for those in the States. So when we look at the amount of calculator, the parts per million of the cations, there's a calculation between the CEC and it shows you the amount of kilograms per hectare. So to get 70% in a clay soil, you might be looking at 5,000 kilograms of calcium. So the easiest way to work out what you need to do as far as the calculation of how much a kilogram of calcium or how many kilograms of calcium it needs to change the requirement of the soil, the base saturation of the soil. So let's say we started it in really simple terms, and this was 50% and we wanted to take it to 70%. And we had 4,000 kilograms of calcium. Now this isn't completely accurate, I just want to show you how the equation works. So if you divide 50 into 4,000, you'll see you'll end up, should be 4,000 over 50, you'll end up with 80 units. So we drop off the naught, 5 until it goes 80 times. So for every percentile, 1%, if you want to move the base saturation, for every 1% you want to move the base saturation, you need 80 kilograms of calcium. Now this equation works on all the soil tests. When you get them back, you'll see them. It has on there the kilograms per hectare, the parts per million, and the base saturation. So if you see that you need to move the base saturation 10%, that means, well, in this case, we want to move it 20%. So we would then calculate that. We'd go 20 times what it took to move it 1%. So we put down a naught, down a naught. So look, we need 1,600 kilograms a hectare of calcium to lift the base saturation from 50 to 70% in this equation. Now, if we're looking at a high quality limestone, limestone's around 30%, 33% actual calcium. So we're going to times that by 3 to actually get the actual amount of limestone. Because like for every 1 kilogram of limestone, you're getting 330 grams. Or for every ton you're getting of limestone, you're getting 330 kilos. So all we need to do is take the kilograms per hectare and times it up by 3, and we get 4,800 kilograms of limestone to increase the base saturation to 70%. And I'll go through this calculation on the soil test very shortly, but this is how these processes work. Now, that's how it works in this situation. If we change it to from this clay soil to a cation, to the sand soil. So remember this, like on the clay soil, we needed 4,800 kilograms on the clay soil of limestone to lift the base saturation by 20%. Now, if you take the equation of a cation exchange capacity of 4, at 50%, you're looking at maybe 1,000 kilograms of calcium a hectare. And you want to move 20 points. So the 50% divided into the 50 over equals, to move it in the sand soil, you just needed 20 kilograms of calcium per hectare. 20 kilograms of calcium per hectare to move the base saturation 1%. Okay, so it's a quarter of the size. Effectively, we were looking at a quarter of the cation exchange capacity, and it's a quarter of the size again. So in this case, say we want to lift it by 20%, we go 20% rise times 20 kilograms of calcium per hectare equals 400 kilograms of calcium per hectare required on a sand soil to lift it by 20%. So if we do the equation times 3, we're only looking at 1,200 kilograms of limestone to lift the pH in the sand soil by 20%. Now, there's a whole lot more to these equations, and I'll go into them further, but this is the significance of understanding the size of your soil and how we're trying to arrange it and put it in place. Things change too, like say, now that's with a limestone product. If with a magnesium issue, maybe you've only got 4%, maybe you're trying to grow berries, or maybe if you're growing berries and that, you might want to get this up to 15 to 16%. So then we have to go and do the equations exactly the same with what we do. Perhaps we only want 15% and 50% calcium, and this would be for growing berries. So what we have to do is understand that these are, or can be, changed around to suit the crop that you're growing. In New Zealand, if we're growing kiwi fruit, we'd want to see this up around 4 or 5%. That happens quite naturally, but we can show you how to look at those equations, find the products that you need to put on that will actually help sort those issues and get things functioning. So that's the base saturation. It's only a percentage. When you have that percentage, you have to have the cation exchange capacity, you have to have the parts per million of calcium, which is then calculated in, the parts per million of the cations, then it's calculated into the kilograms per hectare, and then you have the starting point to make those changes that you'd like to make. Now, I don't recommend at any stage to go and put 4,800 kilograms of limestone on a clay soil unless you are totally cultivating and you can mix it right in with the biologicals. That much limestone on the top of the soil at one big hit's just too much, but we will keep going and working through these issues.